Question which I asked before, like, why is there no proof of work in your proof of stake blockchain? Wouldn't it be more secure if there would be proof of work?
Well, I mean, if you want to use more power than Switzerland and have low performance, yeah, proof of work is great. The thing about proof of work and proof of stake is that, we'd like to pick on proof of work, but if you look at a consensus algorithm, you can break it into 3 phases. There's the deciding who's in charge, there's the person who's been selected doing something, and then there's the network accepting it. So proof of work does the first part through basically a meritocratic lottery. And you have to, over time, do more and more work, use more and more energy consumption, and there's no way to reduce that. Because, well, the more valuable the token gets, the more work you do, right?
Isn't this the purpose, to have resource consumption in
order
to increase the security?
And so then there's a question of whether that's necessary or not. And so this was actually an academic question, and we didn't know the answer to it. We spent 5 years doing research and development where we modeled meticulously the security properties of proof of work and a ledger. We called the GKL model, 800 citations. Everybody in the space cited it, even if you don't like us. And then we systematically built up all the security properties with proof of stake, and we showed that proof of stake can actually achieve that same step. You can synthetically pick somebody and achieve the same security.
Isn't it then equivalent to proof of work, meaning you would probably do something like signature mining or...
No.
You
just use VRFs and other crypto magic, and it just all sorts its way out. Solved problem. Peer-reviewed. Crypto magic.
All right.
But reasonable people can disagree, and that's why there's always going to be a market for proof of work blockchains. The science can only take you so far. There are some things like, do you like exogenous control or endogenous control? I.e., do you like people who are outside of the system controlling it, or do you like people who are inside of the system controlling it? So mining, the people live outside of the system. They have something that's not the system that's used to secure the system. With proof of stake, all the security comes from within. People who hold the tokens are the people who get to decide where the chain goes. Now, my argument is I like endogenous because the people who own the system are the ones who are maintaining the system, so they have a financial incentive to actually be honest. With mining, the problem is that if you have another chain with the same hashing algorithm with a similar amount of hash rate, you actually have an incentive to destroy one chain, short it, and then switch your miners over to the other chain. You're not loyal to it. You're kind of like a mercenary. And this is the problem with exogenous control. Although there's ways you can get around that, and there's all kinds of creativity, and we actually do proof of work research. We have NIPA-POWs, and that's been a whole line. Yeah, and it's great. NIPA-POWs are wonderful. And then we also are looking into useful proof of work as well. So the ship hasn't sailed there, but it is definitely a great topic, and it's a great fun debate to have. So state channels and payment channels, what are you guys doing with your project with that?
Yeah, thanks for asking.
Well, yeah, you're like the only Erlang chain, so we got to love you guys.
We have...
Aeternity, right?
Right.
I'm just being a dick, I'm sorry. Oh, wait, you got your own mic, okay.
So the state channel, it's good that you're mentioning this. They're Turing complete. You can have the Sophia smart contracts inside them. The language which I explained earlier, which is a functional language written by industry veterans running on this virtual machine, which we also built. So you can have smart contracts which are private and scalable, meaning they can have an almost infinite amount of transactions in parallel with a smart contract inside, which only in case of disagreement, in case one of the counterparties essentially wants to cheat or goes simply offline, then can be enforced, can be published or will be published by the other party to the blockchain, the smart contract code, as well as the state, and then it gets enforced by the network, by the consensus, global consensus, essentially. So this was in short how it works. Payment channels are essentially a simplification where there are no smart contracts inside, or the most simple smart contract essentially to just transfer value from A to B with lightning speed. We're going to launch very soon a state channel demo. It's going to be a coin toss demo which will showcase essentially all the good features of the technology which we built the past years by our people, with our language veterans. And it's going to showcase as well this force, progress, blockchain escalation, where essentially a random number gets hash locked, published by Casino, hash locked first and then published, and this way the smart contract can essentially enforce the outcome of the game in case the casino wants to cheat.
Yeah, so it's really interesting, you know, these technologies of, well, do you run the smart contract off-chain or do you run it on-chain? The fatal flaw of Ethereum is that it's like basically everybody lives at the same table. You know, you keep adding chairs around it, so as you gain more validators, you don't actually get any more tables real estate. You don't get any more processing power for the system. So the question is, how do you create a system that gets faster as you gain users, or at least performs at the same rate? And this is actually a super, super difficult thing. And it's the reason why Ethereum 2 is not shipped yet. And it's the reason why we look into things like state channels. We're actually doing research as well there, and I respect anybody who's chasing that down because it's non-trivial. And then there's a question of, well, what are you even processing and running? So when we first created Ethereum, we said, oh, well, wouldn't it be so cool to just reinvent the whole internet and put it on a blockchain? Yeah, you know, that was Stefan Tual's marketing after I left, because it's stupidity. It's absolute idiocy. You can't do it. It's 1,000 times more expensive. It's 1,000 times slower. It's not a good idea. Instead, what you have to do is break your application apart, and you say, well, certain parts of the application should probably run on a server or in a private database. And other parts where you don't want to trust that central actor, maybe your money, your account management, your identity, your policies behind access control, let's put that component on a blockchain. But the reality is that's only a small component of your application. And that's the smart contract. That's what the network should process. And in many cases, there are components of that which are private. The problem with the Ethereum model is that, well, it lives on a public blockchain. So when you're processing it, it requires all the data inputs and outputs to be unshielded, meaning that everybody can see it, everybody can interact with it. You get no privacy in the computation. So imagine going to a hedge fund and saying, would you be comfortable with your entire trading strategy being transparent? Or going to a health records company and say, would you like all the brokering and movement of health records and perhaps the records themselves to be public? You can't do that. Right? So then how do you run these contracts either off-chain or on-chain with a way that preserves privacy? And so state channel is actually a good idea, and there's some merit to that, and there's some good concepts there, and it's something we look at with Cardano.
How do you scale?
So that's a good question too. And so the question is, well, how much scale should you have? So how much should live on-chain, how much is off-chain, and what can a single shard environment get you? I think peak performance in a single shard environment is probably somewhere around 150 to 250 transactions per second under realistic network conditions. It is very easy to take a BFT protocol and just throw that thing on a normal blockchain, permissioned, on a single computer, and create beautiful benchmarks. 50,000, 100,000, 200,000 TPS. And the minute you put it into a real network with latency that has to send packets across the internet and back and communicate, and you have that communication overhead, then you see this huge decline in performance. Every single system experiences this. This is why EOS was able to say they had such great performance, and then when consensus benchmarked the system under realistic network conditions, suddenly the performance decayed to 250.
So we have 117 on public mainnet.
Which is great. That's a high performance chain. So right now we're looking at, we actually used Ethereum as a unit of measurement. So we took Ethereum at peak performance during CryptoKitties time, and we said that's 1 Ethereum. So right now, unoptimized, the system is running at 5 Ethereums, which is around 60, 70 TPS. Not too bad. It's unoptimized. And the question is, could we get that further? Sure. If we upgrade Ouroboros Genesis and we go through the whole Ouroboros line, probably get that to 150 to 200. But that's just the base ledger performance. But then when you put layer 2 protocols on, with Ouroboros Hydra, and that's what we're publishing in February, we can scale that easily to thousands of TPS. Okay, but it's running on a different network with a different security model and with different assumptions. Now, if you want to go faster on the base layer, You can do ledger sharding, but there's always a trade-off with that, which is your security goes down. You go from 50% Byzantine resistance to a third to a quarter, and if your network conditions are suboptimal, you do not actually gain benefit from the sharding scheme. This is why F2 is such a nightmare, because they can't get what they want.
So we are looking forward to this year, essentially, that we're going to see many applications launching on Eternity blockchain, doing a lot of transactions. So we want to fill up this 117 transactions per second, which are possible right now, which are timestamped on the mainnet already in past blocks. And yeah, we are kind of like working now on a new consumer product as well, which hasn't been announced yet. It's a crypto overlay over the web.
Right.
Yeah, how, I mean, I saw that you launched a testnet.
We
December.
did. We did.
There were some issues with that. I wondered afterwards, what is actually the current mainnet with Cardano doing?
In terms of performance or in terms of transaction rate?
I mean, the functionality or...
Oh, I mean, it's as functional as Bitcoin. It's basically like Bitcoin had sex with Ripple and they had a really weird child. So obviously you don't want to go down that road, so you'd like to upgrade at some point. So Shelley's coming soon, and the incentivized testnet was exactly what we expected it to be. I mean, we expected maybe 100 stake pools. We're at about 900. About 40% of the network is participating, which is really good, all things considered. And week by week it gets better. There's still some shaky networking, but the point was to build up a stake pool population, test out the staking user experience, and then to get a better sense of how all the components fit together, Daedalus, the wallet backend, and the node. So from that perspective, it was an overwhelming success. And you as well as us, we both use similar development methodologies. We work both with John Hughes, and we do property-based testing. So when you actually talk about the final product, that's a very different animal, and unfortunately it's being built in a very rigorous way, which also means a very slow way. So the Shelley Haskell testnet should come out soon, probably a month or two, and then we'll just run that until we have a high degree of confidence, and then the mainnet will come. But the point of the incentivized testnet is people make money off of that thing. Every time you make a block, you actually make profit, and so it's actually paying people to beta test the software. And this is why we have tens of thousands of people using it and thousands of people in our Telegram staking channel. And we even have our own community members generating statistics, doing daily updates, building their own explorers and dashboards, issuing issues on GitHub. The response was just overwhelming. And I think Ethereum, like they love copying us, is starting to embrace a similar model with S2 and the way they've structured their testnet. So we're very happy with that, and we're very happy to launch the product soon.
Did Tron also copy out of your white paper?
No, they copied Dan. I think they're the only people who actually did. So they have the same sins.
Guess what?
Are you going to leave us, Eric?
No, I'm not going to leave you. But you are finishing gracefully, beautifully, with one last question. Hello, microphone, thank you. Yes. Oh, out there. Hello.
Okay.
And I need to move this side. That's it. I got it. Because it's you two, you're entitled to one more glorious question. Down in the front here, I'm going to...
Yes, sir.
Please say your name and then your question.
You got that look like you got a ringer. You've just been waiting all day.
For Yanislav, background question. You've come up with a new programming language. Why not, for example, Solidity has 100,000 developers, and JavaScript is a...
Yeah, why didn't we use JavaScript?
Millions. Why not, for adoption?
Right. Like when you study programming languages, you will notice certain patterns, and you will be able to distinguish which are better designed programming languages and which are not. I mean, for this, you would really need to study somewhat computer science, essentially. Charles knows what I'm talking about.
Yeah.
It's pretty clear for the people, like the experts. And JavaScript was not a well-designed language. Right now, I mean, it got improved a lot over the years, obviously, but it's also not made for blockchain. So we integrated higher level concepts like oracles, like state channels, like names, in future also tokens into the programming language to make it way more explicit in the smart contract how to essentially do certain things, so to eliminate also programming errors, because we essentially are working on a higher level. There's, for example, this French blockchain, what was it called?
Tezos? They're
I
pretty
think so.
French.
Yeah, they're kind of like doing assembler coding.
Oh, that's a
smart
different one.
contracts.
Oh, that's the guy who wears
Are
the guy who wears the hat, the little bidet, right?
I think it's
That weird French dude, right? He always carries the baguette.
Anyways,
He came to my
this is exactly
conference.
the opposite
Nice
of
guy.
what we are doing. So we are really working on the highest level to essentially make it super easy, super simple, super safe as well, super productive as well for the programmer, for the developer to create these applications, decentralized applications. And if you have a assembler type of language, then you need to really understand how essentially the machine works in order to do the program right. So you're not abstracting at all. It's not a higher language, as computer scientists say. So yeah, we're making developers as well as entrepreneurs' life as in fact way more nice.
So
Well thought through.
I'll take a crack at that because I created my own programming language too. I actually wrote two of them, Plutus and Marlowe, and they're both functional as well. One is a DSL, and the other one's a Turing complete functional language based on system F omega. So it's a reasonable question of, well, why another language? And we now live in a polyglot programming world. If you're an application developer, you're generally used to dealing with multiple languages and multiple tool sets. And so the key when you're talking about the development experience for smart contracts is saying, keep the familiar and old as much as you can, and then when the new is necessary, make the new comfortable. Okay? So the reality with all blockchain, you're going to need a new programming paradigm because you're interacting with kind of a different type of animal. It has assets and information and metadata. It's a distributed system. It has synchrony issues. So this is not a normal thing that you're playing around with. It's a different structure. So it kind of does require bespoke code. Whether you write that logic in Java or Solidity or Haskell, you're still doing new things with new design patterns and new ideas. So that alone does require the programmer to learn new stuff. So the question is, how much new stuff should they learn? And, okay, there's 100,000 Solidity developers. Well, the reality is there's probably 500 good ones, and there's 99,500 who are playing around with it, right? And then you actually look at the really solid Solidity applications, and the reality is the vast majority of the deep logic of those applications is written in JavaScript. And then they write it as a Node app or Java, and they write it as a Java app, and then they connect it using some sort of bridge to Ethereum, and they run most of the code off of Ethereum for scalability and cost reasons, okay? So the way we designed Plutus is that we said, hey, we have the on-chain code and the off-chain code. And we're going to use Plutus kind of a bridging language that allows you to write your application the way you want to, then connect that application to Cardano. And then we have DSLs that let you manipulate assets, information, and metadata. So the flow of information like oracles, assets, like the movement of value, and then, of course, the use of metadata, identities, these things, okay? So that model is nice because when you tally up all the code, 95% of your code is familiar. And it's using the frameworks you come to know and love. And the 5% that's not familiar has been bespoke constructed to deal with your system in a way that's safe. It's just like when SQL was created for databases. You could technically create tables and access these things with assembly if you wanted to. But it's nice to have a DSL that has specific instructions pre-built to interface with the database and take care of a lot of your difficulties. So yes, you can do it with many languages. We even chased something called K and Yella, and we were looking at semantics-based compilations, so we could find a way to be interoperable with all these programming languages. But the reality is that that's a Pyrrhic victory at best. You build special tools, and there's a reason to use these tools. You make them accessible. You put them into experiences people are used to, like Remix IDE. You give it to the developer, and then you give them a way of seamlessly connecting that to normal development experiences. And then when you combine both of them together, you can actually build something useful for somebody with maintainability.
And I was just asking that from the point of view of, blockchain needs to cross the chasm, right? Right now, it's kind of the realm of the geeks. To go into the other world, that's like
every programmer is a geek. You're not going to escape that, whether it's blockchain or not.
I'm afraid, I mean, thank you for a nice short question. It was awesome. Thank you both ever so much.
Sorry
Much
for being
appreciated.
late.
Big round of applause. Very much
A lot of fun. Thank you, sir.
Thank you. And this battle is called the Battle of the Blockchain. I'm not always that critical, but I'm also a really cool project. So.
Yeah.